Hello there and welcome to Chemistry Made Simple. Now in this video I'm going to introduce you to GCSE atomic structure. So this is starting from zero knowledge. So if you've never done atomic structure before or if you need a refresher, this is the right video for you. So I'm going to cover with you what an atom actually is, what atoms look like, subatomic particles, so the building blocks that make up atoms, and I'll talk you through atomic numbers and mass numbers. It would be really helpful if you had a periodic table with you for the duration. So this is a model that shows us what an atom looks like. So firstly, what is an atom? It's the smallest part of an element that can still act as that element. And as far as we're concerned in GCSE chemistry, there are three building blocks that make up an atom. We've got protons, neutrons and electrons. The next thing to bear in mind is that atoms are really small. They reckon a piece of paper is equivalent to the thickness of about 1 million atoms, so that gives you an idea of how small they actually are. Now importantly, we've got two distinct areas to an atom. We've got a nucleus here, and that's a tiny dense bit in the middle, and that contains protons and neutrons. Then we've got these things called electrons, the yellow particles, and they orbit the nucleus in what we call shells or energy levels. So we need to know a little bit more about these subatomic particles. Now, firstly, protons and neutrons have both got a relative mass of 1. So relative masses compare the mass of one object to another. So what that's telling us is that protons and neutrons have got a mass that is about the same. Now the relative mass of an electron is often quoted as 1/1836. Some exam boards might describe the relative mass of an electron as negligible. Now what does that mean? That means that if you've got a proton, it would take about 1836 electrons to have the same mass. Now relative charges, protons and electrons have got opposite charges. So a proton's got a relative charge of +1, an electron's got a relative charge of -1, and a neutron has got a relative charge of 0. Now atoms never have a charge themselves, and the reason for that is that the number of protons and electrons in an atom is always exactly the same. So let's go over the layout of an atom again. So, in the middle, we've got the tiny dense nucleus containing protons and neutrons. Now, protons have got a positive charge, neutrons have got no charge at all. And around the nucleus orbit things called electrons that have got a negative charge. So that's how we could show an atom at GCSE. Quite often the electrons are just shown simply as either dots or crosses. Now don't forget, because protons are positive and electrons are negative, atoms have no overall charge. So an atom has always got the same number of protons and electrons. Okay? I'm going to show you how to work out the numbers of protons, neutrons and electrons very shortly. Now every atom on the periodic table's got two numbers associated with it. Let's find argon on the periodic table. So symbol Ar. It's got the number 40 and the number 18 associated with it. Now, these numbers are given two different names. Okay, so we've got the mass number and the atomic number. Now, the atomic number is the number of protons. Now remember, because atoms have got no charge, the number of protons and electrons in an atom is always the same. So it's the number of protons or the number of electrons. So every atom of argon has got 18 protons and 18 electrons. Now the mass number is the number of protons added to the number of neutrons. So that means in this particular atom of argon, the sum of the number of protons and neutrons in the nucleus is 40. So how do we work out the number of neutrons? Well, we get the mass number and we subtract the atomic number. So the number of neutrons is 40 minus 18, which is equal to 22. So therefore, in this atom of argon, we've got 18 protons, 18 electrons and 22 neutrons. Now it's important to realise that the atomic number and the mass number have to be whole numbers. It's impossible to have half a proton or half a neutron. I'll explain in a later video why on the periodic table some of the mass numbers aren't whole numbers. That's because they're relative atomic masses, but that will come later. Now let's have a think about electrons in shells or energy levels. Now we number shells or energy levels starting from the closest to the nucleus. Now, as I'm sure you can imagine, these shells or energy levels get bigger the further you actually get from the nucleus. Now at GCSE, you're required to draw elements numbers 1 to 20. That's hydrogen up to calcium. And this rule will work for everything that you've got to do at GCSE. The first energy level, the closest one to the nucleus, can hold up to 2 electrons. When that shell or energy level's full, we move on to the second one, which is bigger, and that can hold up to 8 electrons. Now the third one, as far as we're concerned at GCSE, if you learn its maximum of 8 electrons, that will get you through GCSE. In practice, the third energy level can actually hold more, and you'll find out at A level and beyond it could actually hold 18. Now, at GCSE, we do elements 1 to 20, so atomic numbers 1 to 20, hydrogen up to calcium, and that will leave a maximum of 2 electrons left to put in the fourth energy level. Fourth energy level, if you're interested, could actually hold up to 32. But this 2-8-8 rule will get you through everything at GCSE. So let's pick an element from the periodic table. Let's go for fluorine. So symbol is F, and its mass number is 19, and its atomic number is 9. Therefore, in this atom of fluorine, we've got 9 protons, 9 electrons, and 19 minus 9, which is 10 neutrons. So if we look at the nucleus then, we can put our 9 protons and our 10 neutrons in there. So 9 protons and 10 neutrons. And then we've got 9 electrons. Remember, we can put 2 in the first energy level and our remaining 7 in the second energy level, just like that. That's what an atom of fluorine looks like. So if we find an atom of boron, it is 11, 5b. So that means we've got 5 protons. We've got 5 electrons, so 2 in the first energy level and the remaining 3 to go in the second energy level, and 11 minus 5, which is 6 neutrons. So if we pick a bigger atom, this one with 3 energy levels, let's choose aluminium, so Al, and we've got 27 and 13. So we've got 13 protons in the nucleus. We've therefore got 13 electrons, and that's going to go 2 in the first energy level, 8 in the second energy level, and we're going to put our remaining 3 in the third energy level, so 1, 2, 3 like that. And then the number of neutrons, 27 minus 13, so therefore 14 neutrons. And finally, let's have a look at argon, because that's where we started. So if we find it on the periodic table, we've got Ar 40, 18. So therefore in the nucleus we've got 18 protons, we've got 18 electrons, and it's going to go 2, 8. Now 2 plus 8 is 10. So therefore we've got another 8 to put in the outer shell. Now the number of neutrons, that is 40 minus 18, which is 22 neutrons. So that's an atom of argon. So thanks for listening. So that's GCSE atomic structure, hopefully made simple.